AP Physics, Day 3, problem number 12 from page 85 of the homework. In this problem, it's a speed versus time graph. We're going to assume that the cyclist is going in a straight line, and let's say forward. So the vertical axis here represents the speed versus the time, but really it's the velocity versus time. Because if the cyclist is going in a circle or some curvy pattern, you really can't do the problem. So we're assuming they're going in a straight line. Let's start with the easiest part of this, part number 2, or path number 2, which is a straight line from this lower point at time 2 seconds with a speed of 1 meter per second, increasing up to 6 meters per second at time 7 seconds. So there's 5 seconds involved. So that's the easy one. There's one line, that's one slope. The slope represents the acceleration if we assume this is a velocity graph. So, and the equation simply is, as you all know, the acceleration, the average acceleration, that says average acceleration there, is delta V over t. And that would also give you, in this case, when you have a straight line, it's the rise over the run. Delta V is the rise, and delta t is the run. It's rise over the run. So in the 2-second path, the average acceleration, and you will see a shortcut here in a minute, the delta V is an increase of V final minus V initial, so 6 minus 1 is 5. I'll write it down. V final minus V initial over a time of 5 seconds. And that vertical axis is meters per second, and the horizontal axis is seconds, so it's going to come out in meters per second squared. So the average acceleration is, well, 1 meter per second squared, because 6 minus 1 is 5. And we're going to call that positive. We're assuming we're going to what we call the positive direction. And that's one acceleration, one average, one steady acceleration. So it would be the steady acceleration for that time period. Well, in path number one, it doesn't maintain that acceleration. To find the acceleration at any given instant in time, you'd have to take a tangent. For example, if you wanted to find the acceleration at this time right here, which is about 2.5 seconds, you would need to draw a tangent line like this. That's not a very good tangent. Try to do a little better job. Draw a tangent line like that and find the slope of that tangent line, and that would be a little bit steeper than the 1.0 meters per second we had in part, or the one I just did for the 2-second, or the path number 2. But that acceleration is changing. It's getting more than that. Then it actually starts off real steep, then it gets flatter. So the acceleration is changing. It's not a steady acceleration. However, the overall average acceleration still is the same as path 2, because if you just take V final minus V initial, that's the nice thing about looking at 2 points in the motion. The average acceleration is still the same, even though it changes from the 2-second to the 7-second time period. It starts off as a very, very high acceleration. Then, just after that point I graphed, at about 3 seconds, there's kind of a gear shift or something. The acceleration almost goes to 0. Then from about 3.7 seconds up to about just over 4.5 seconds, it's accelerating again. Then it kind of flattens out, or it's maybe a gear shift. So every time it kind of flattens out, there's not much of acceleration. But every time it's steeper, there's a large acceleration. So the acceleration is fluctuating, but it's still going to average out at 1.0 meters per second squared. Same thing is true for that third path, path 3. The acceleration starts off as 0 from 2 seconds to 4 seconds. It's just sitting. The speed is constant. They're not sitting still. They're moving at 1 meter per second. Let's say straight forward in positive direction for 2 seconds. Then at that time, there's a very large acceleration, a steep acceleration from the 4 seconds to the 7 seconds. So it's greater than 1 meter per second squared. But once again, path 3 still gives you an overall average of 1.0 meters per second squared, even though it's more than that for that second, the 3 seconds at the end, but it's 0 acceleration for the first 2 seconds. So bottom line is same acceleration for all 3 pathways.